have. Again, working under the assumption here that acceleration is constant. If acceleration is not constant, this would not be true. This is true whether it's a constant or not. So what's 1/2 VI plus VF? Well, what would you kids call it today? Youngins? Young adults? I don't know, what's the right term? You post Star Wars babies. I assume none of you were born before 77. Okay. Post Star Wars. Post disco. Anyway, I have two numbers that I add together and then I multiply times 1/2.
Average.
Yeah. So we have that the average velocity is just basically the average of my first and last values. So if acceleration is constant, again, so if the jerk is 0, then my average velocity is just my initial velocity plus my final velocity divided by 2. So we actually have right there all the pieces we need in order to have the second one. A second equation here, because I have a formula here that's going to be true whether acceleration is constant or not, and then specifically if acceleration is constant, we just plug that in there, and we get rid of that. And we have my displacement is equal to my initial velocity plus my final velocity divided by 2 times time. So we got now 2 of the cake formulas. That dramatic pause there was for any questions. All right, let's take it to the next step. Let's see. Well, we could pull it from that, but let's do it the calculus way. So if I know that my velocity is equal to my initial velocity plus acceleration times time. Again, we are working with the assumption that acceleration is constant. I know velocity is also dx dt. Then I want to solve for x. So what I'm going to do is multiply both sides by dt. So dx is equal to vi plus at dt. Distribute. So dx is equal to vi dt plus at dt. And we'll integrate here from some initial position to some final position. Here from time 1, or time initial to time final. Let's just go ahead and make it 0 to time final and 0 to time final. Or just the time. And what do we get? piece by piece. Well, we start over here. The integral of some constant times time dt. All right. What's going on? What's the problem?
I really think my foundation of calc is not where it should be. Looking at this,
If I did, if I wrote it like that, does that seem easier to you?
yeah,
What would that be? You want to tag somebody to help out, or you got it? You want to attempt it yourself?
I'll tag somebody.
Whom will you tag? If you're struggling with names, you can just point. All right, Ben's been tagged.
Is it 2t squared?
Yeah, 2t squared. How'd you get that?
Looked it up.
No. It'd be nice if you didn't have to look it up, but why don't we talk a little bit about some basics there on the calculus? We're not getting the calculus we need. What you do in calc classes, you go into far more detail than we do here. You should be able to do sine and cosine and polynomials. That's in essence the calculus level that we're doing here. We'll stick with x's. All right, so if I have a function like that, if I'm taking a derivative, I guess my question is, how comfortable are people with doing derivatives? All right, I got 2 nods of comfort there. I guess that's just the 2. All right, when you're doing a derivative, so you're basically, you have some function here, and what we're doing is we are looking at the slope. The formula for the slope, you take the exponent, multiply it times the coefficient, so it's that times that. So I get 20x, and then I subtract 20x cubed. Looking for glimmers of recognition. Okay, I got some nods there. All right. So if y is equal to 2x cubed, dy dx would be, have an answer in your head before someone works it up, so give everyone a moment. And then someone word it out.
6x.
Yeah. So you multiply times the coefficient, subtract 1 from the exponent. When you're doing an antiderivative, you just do it in the reverse order. You add 1 to the exponent, and then, so we multiply times the coefficient, subtract 1. To do an antiderivative, you add 1 and then divide. So if dy dx is equal to 2x cubed, y would be, well, add 1 to the exponent, and then divide by that new exponent. That becomes 1/2 x to the 4th, plus some constant. Now the constant, let's go back to doing derivatives. If y is equal to 4, there's an implication of, well, 4 times 1. So that's the same as 4 times x to the 0. So if I do a derivative there, use that notation, you multiply 4 times the exponent, which is 0, times the x to the, I don't care. I mean, multiplying times 0 here, so equals 0. So the derivative of constant is 0. Another way of looking at it, since a derivative is a slope, a constant function is horizontal, and the slope of a horizontal line is 0. So that's where the plus c comes from. This is known as an indefinite integral. Well, what is a definite integral?
One with a specific range.
Yeah. So these are definite integrals here, and so let's go through and do one of those real quick. Equals integral of, we'll just say 6x squared from x is equal to 0 to 4. And so this would be y. Basically the integral and the d cancel each other out, crudely speaking, from 0 to y equals, well, x cubed, 6x cubed divided by 3, 0 to 4. And so we end up with y equals 128 minus 0. If x is, oh, sorry, if we had included the plus c, so let's squeeze that in. If we had plus c right here, like we did for the indefinite integral, then we'd have 128 plus c minus 0 plus c, because you're taking that, you plug that in, minus that, plugging that in. And so the c's would cancel out, and so that's why typically they're not written, because they're just going to go away. Bring back some fond memories for those who are feeling a little bit sluggish on it. Or at least memories. So now we're back to questions before we connect it to physics-ish. All right, so I have some constant times time, that's time to the first power. Sort of treat it like that. I have an exponent, understood exponent of 1 there, so I'd add 1 to the exponent, and then divide by the new exponent, and we get what Chance told us. So I add 1 to the exponent, and then divide by that new exponent, and I get that from 0 to t. Here, this is the initial velocity. It is a constant. It's not just some generic velocity, it's the initial one. So what would this be equal to?
Itself, the initial velocity.
I need a little bit more of that. The initial velocity definitely is there. What about the integral?
Oh, the initial velocity times t.
Yeah, times time. from 0 to d. And then this, in essence, if there's a 1 sitting in front, I guess, writing it out slightly more formally, or in a longer way, integral of dx is the equivalent of 1 dx, or 1 x to the 0 dx, whichever form works best for you. What would that integral be? Yeah. Or treat those as sort of inverse operations, they cancel each other out. So what I'm left with is x from some initial value to some final value. Well, here I stick in xf minus xi, so the top one, stick it in, bottom one, subtract. This is just the change in position, or displacement. Here, we get the initial velocity times time, plus 1/2 acceleration times time squared, and we have another equation, a third. It helps if I don't use the markers on these. So I have two displacement formulas here. I got the average velocity times time, and then I have vi t plus 1/2 a t squared. And one more, because I don't think your textbook does the fifth one. Most textbooks don't, but occasionally a textbook will give you a fifth equation. Do a quick scan. It does not look like, actually they barely give you these. All right, let's tackle that next one. A number of you in Calc 3, have you done dot products yet?
Yeah. Working on it.
Working on it, okay. What's a dot product? Or is it too soon?
A little bit.
You said a little bit?
Was the first times the second first one, and then plus the second times this.
All right, so the way you were, I'm not 100% sure what you meant by first and second, but it almost sounded like you were doing a cross product there. Have you done cross products yet? All right, so I got a nod on that one, and a couple of stares. A head shaking no. All right. When dealing with vectors, this is vector math, there are two ways of multiplying: dot products and cross products. So if I want to multiply, if I have two vectors A and B, if I do a dot product, A dot B, cleverly called a dot product. In math class, they talk about what other names there are for this. Okay, I'll take that as a no. Scalar products, scalar product. And something, it will eventually, I think, get to, I can't remember Calc 3. It's been a couple decades. It's also sometimes called an inner product. I will tend to call it one of these two, usually dot product. Scalar product, this might be the last reference I make to inner product. When you're doing a dot product, you're multiplying parallel parts. So if I have, so if A is 3i hat plus 4j hat, and B is negative 2i hat minus plus 3j hat, if I do a dot product, I multiply the parallel parts. Well, I hat, those are parallel to each other. So that's 3 times negative 2, which is negative 6, plus multiply the j hat parts together. and I get 12. The answer is a scalar, thus calling the scalar product. There is no vector in the final answer. Let's say that you get into a test and you suddenly blank on dot products. Let's do it a longer way, show that you come out with the exact same answer. So I have 3 I hat plus 4 j hat dot negative 2 I hat plus 3 j hat. And I hat, j hat are perpendicular. That's really the only thing that matters. The direction of I hat and j hat is irrelevant, just so long as they're perpendicular. Let's FOIL. First, I get negative 6 I hat dot I hat. Outer plus 9 I hat dot j hat. Plus inner negative 8 j hat dot I hat. Plus 12 j hat dot j hat. Obviously, a longer way of doing it, but we get to the same place. So first, I hat times I hat. What's the magnitude of I hat?
1.
Yes. So since I'm multiplying parallel parts here, I got this 1 I hat times I hat. Well, every vector is parallel to itself. So those are parallel to each other, and so you just multiply them. So that's negative 6 times 1 times 1, or negative 6. I hat and j hat are perpendicular, so what would, if I'm multiplying parallel parts, what would I dot j be? How much of I is parallel to j?
Still 1. Still 1.
Nope, not 1. How much of I is parallel to j?
None of it. None of it.
So I dot j would